Buzz Powell will speak next on NCAT and MnROAD activities. Buzz Powell is an Auburn University research professor and associate director at the National Center for Asphalt Technology. Prior to working at NCAT, Buzz worked for Regis Engineering Solution and as an assistant testing engineer with Alabama DOT. He collaborates with MnROAD colleagues to expand pavement preservation field testing to include no-freeze and freeze climates.
Good morning, everybody. I appreciate the opportunity to visit with you this morning and provide you with an update on the NCAT plus MnROAD Pavement Research Partnership. It's a two-part partnership, and half of it consists of mix and materials research with asphalt plant mix. The other half of it is all about pavement, all different types of pavement preservation. And obviously, that's the update that I'm going to provide you with today relating to these two programs. So the content of my experiment, and I'm going to go through this as quickly as I can so that I can keep this experiment as practical as possible for participants and not get too technical with it. But now, just very briefly, how did we design the experiment? The whole objective of this thing is to quantify the life extending and the condition improving benefits with experiments at both locations, or test sections at both locations, NCAT and MnROAD, the southern sections and the northern sections. I really want to focus on practical findings and takeaways. What can you take away from this experiment that we've learned so far that you can implement potentially in your local agencies? So everybody's familiar with the pavement deterioration curve. You know, when we can get to things early, it's preservation. When we let it deteriorate, now we're into rehabilitation or reconstruction. Obviously, with preservation, we want to stay in the high part of this curve. And really the whole point to this experiment is, how do we select our options for agencies of different sizes, cities, counties, and state agencies? How do we select the options and do it based on the best investment in terms of cost per mile? We've got lots of emulsion options. We've got Thinlay options that are all up in that preservation category. And what we wanted to do with this experiment was take the pretreatment data that James showed so well in that previous presentation. Think about the areas of the pavement that were cracked and the areas of the pavement that were not cracked. And what we wanted to do was say, as pavement condition changes, how does performance change for each of our preservation treatment options? That information has not been readily available in the past. You know, typically we see tables that say, you know, different treatments on average last this length of time, and it may make some effort to relate back to the level of pretreatment condition. But in probably the majority of cases, agencies kind of back into a position where they say, well, the average length of performance time for treatment A is 5 years. And so that's what they program into their selection process, regardless of pretreatment condition. We wanted to dig deeper into that and relate back, you know, performance back to different levels of pretreatment condition. Now, we started the experiment, you know, the main focus was kind of the conventional emulsion treatment options and the Thinlay options. The more work we've done, the longer we've done work, the more we've gotten into cold recycle work, into reclamation work and recycling through in-place recycling or cold central plant recycling. It's bigger scope than kind of textbook pavement preservation, but it's very useful information to the agencies that sponsor the research. What does the experiment look like if you're not familiar with this? Well, we started all this in 2012 on Lee Road 159. It's a low traffic but high truck count roadway, dead end road, so we have very precise traffic counts. We expanded that to US 280 in 2015. 2015 was when we started our partnership with Minnesota, with the Minnesota Road Research Project. So then now we've got low traffic and high traffic in the south. In 2016, we went up north, you know, with a 1 year offset in the treatment installations, and on County Road 8, County State 8 Highway 8, and US 169 up in a little community called Pease, Minnesota, we built the same test sections up there in the northern environment. In 2019, we had not yet done cold recycling up in the northern climate, so we did 70th Street, which is the access road to the main MnROAD test facility. So we had all different types of preservation treatments and recycling in the southern locations and in the northern locations. At each place, we had standalone Thinlays, we had cold recycling, microsurface chip seals, crack sealing, fog seals, and then combinations of these treatments. I was the person who originally started the experiment in preservation in partnership with all the states and with FP2 back in 2012. And the vision from the very beginning was, let's relate the performance of all these treatments back to different levels of pretreatment condition. Then as we executed the study, Mary Robbins came in, and she was the PI in the research for several years. And then Dr. Adriana Vargas, who is our moderator for this session, she now is the PI in this experiment. She and I work really closely together on this, but a lot of the information that I'm going to share with you is the methodology that Dr. Vargas developed and has implemented now in all of our test locations. And I am very impressed by what she's done and the practicality and the utility of the processes that she has developed. Kind of the core of this is, at least the main thrust of the data is we report pre-treatment condition and post-treatment condition as it changes using the MAP 21 distress criteria for flexible pavement. So that's cracking, rutting, and roughness. We broke all of our pre-treatment pavement area down into the good, fair, and poor categories using these three different metrics. And then we go back on a regular basis and we recharacterize these roads after all these treatments have been installed, and then report these data. And I'm going to show you how you can tap into the data set that is available to the public through our website, and you can kind of do your own research. I'm also going to share with you some really convenient quick summary dashboard views that Dr. Vargas has developed. But what you're going to see is that the changing distress, kind of the controlling distress, for lack of a better way to describe it, in the southern test sections is in the hot weather test sections is cracking, and in the north it's roughness. We're really not seeing a lot of change in rutting at either of the locations. Of course, we do have good materials, good designs, good construction, and good inspection, kind of the four-legged stool that's important for successful performance of these test sections. But as you're going to see, it's pretty much cracking down here that's driving the changes, and it's pretty much roughness up north. Well, this is the dashboard view that Dr. Vargas has developed to give you a snapshot view of the data. The hot weather sections are on the left, and the cold is on the right, and then in each half of the screen, low traffic is on the left-hand side, and high traffic is on the right-hand side. You see red, in the southern test sections, and so that this is the cracking dashboard, and it's showing, what percentage of the test sections are poor and fair and good. You don't see any red over in the cold climate in the MnROAD test sections. Much less cracking up there, and the cracking that we do see up there, of course, they have very aggressive thermal cracking, but thermal cracking, affects only kind of slices of the pavement. So we're subdividing these test sections so that we can capture that in our performance assessment. So cracking is changing down here, and we're seeing that in our data. We're collecting a lot of other data outside and beyond the scope of MAP 21. MAP 21 is what I'm sharing with you today because that is a primary focus, at least for state agencies that are having to report their condition assessment data to FHWA. The rutting dashboard, you don't see significant rutting in any locations with any of the treatments that we've placed. And I think that's a good indication that we had really good materials and mixed designs and good effort during construction, and we're just not seeing a lot of change. You see rutting on roadways when you're kind of in the middle of failure. And again, this is a preservation focused experiment. So rutting is just not something that we're seeing change significantly within the experiment. On the roughness side, it's really interesting because in the southern test sections, we're not seeing significant change in roughness. Roughness changes down here in the southern test sections when you're kind of in the middle of failure. Cracking can develop, but roughness is not going to change until we're in the middle of failures. But in the northern test sections, because you got the aggressive thermal cracking, we are seeing roughness change up there because of the cupping and the warping that occurs at those aggressive thermal cracks and the freeze-thaw conditions that they have up at those test sections, where it can be minus 45 degrees at the location of these northern test sections. So kind of the quick takeaway is we got cracking in the south, we got roughness in the north, and we don't really have rutting at either one of the locations. Another one of the innovations that Dr. Vargas brought to the experiment is the idea that let's do these quadrant views where we show at the same point in time. So we've got different ages that are in play here because the southern sections have been installed for a longer period of time. But this quadrant view, in the case of this slide, shows you what all the double layer microsurfaces look like, with the northern sections up top, southern in the bottom, and then low traffic on the left and high traffic on the right. And we're seeing, of course, you can see the thermal cracking up north. Thermal cracking has reflected in I think in all the preservation test sections to different levels of severity. Otherwise, outstanding performance with the double layer microsurface in both the northern test sections and in the southern test sections. You do see a little bit of macro texture change, a little slight raveling on Lee Road 159 because now it's been down now for at this point in time for 9 years. But again, excellent performance, not seeing a lot of reflected cracking. And what I like about the summary that she's worked up for these is the bars on the bottom of these pictures kind of give you that dashboard summary of cracking and roughness and rutting, and in what map 21 range the data is currently falling inside. So this is a similar picture for the 3/4 inch thick BMD Thinlays. These are balanced mixed design Thinlays, meaning that we didn't just load them up with recycled material and do volumetric design and production. We actually experimented with these mixes to make sure that we had good, healthy performance. So the aged binder content mixes they're 20% recycled binder through some combination, in most cases, of RAP and RAS, recycled or asphalt shingles. But we've got good performance with the 3/4 inch Thinlays, similarly, similar to the double layer microsurface that I showed you in that previous slide. And this is what the control sections look like. So we do have some significant distresses that were in these pavements at the time that the treatments were applied. And so it was really important to kind of take that view of the pavement that James provided in the previous presentation and separate out the cracked areas from the uncracked areas, for example. And you see, a lot of alligator cracking on Lee Road 159 and longitudinal cracking on US 280. You see combination cracking on County State 8, Highway 8. You see thermal cracks and then longitudinal cracks on the inside of the edge line there for US 169 up in Minnesota. So we've got a nice diversity of distresses at all 4 of these test locations. One of the big takeaways is that we're seeing excellent performance from really all of the preservation treatments that we have deployed in this experiment. Really good performance at every location, from the emulsion treatments and from the plant mix treatments. Of course, one of the takeaways is the more robust the treatment, the better the performance. For example, when you go from a single layer microsurface to a double layer microsurface, or when you do crack sealing and then do a chip seal or a microsurface. So you spend more money, you do more effort, and you get a longer life extension and more condition improvement out in the future. And really all comes back to, in your market, what is your cost per mile to execute the treatment options that are available to you, and then factor that into the life extension that you get and see what's the best investment for you to make at the current time based on the pavement condition that you have. I'm going to give you a website URL near the end of the presentation where you can do all the research that you want to do on these individual treatments and kind of see what they look like on the ground. But this is a data sheet that you can download from Lee Road 159. This is a really nice sheet that Adriana has worked with Jason Nelson here to develop to give you a snapshot view of rutting and roughness on the top of the page, just simple bar graph for what it looked like before we apply the treatment, what it looked like right after we'd apply the treatment, and then what does it look like now. And then, of course, on Lee Road 159 in the southern test sections, cracking is what we're seeing change. And the cracking plot that you see there, the dashed lines are what would the cracking be had the treatment not been applied, and that's based on pre-treatment condition and the control sections. And then the solid lines are what is the cracking with the treatment applied. So essentially, you can kind of think about this as the gaps in between those lines provide us with condition improving and life extending benefits. And what you see is when the pavement's in better condition, those lines are flatter over time, and then there's a there's a summary of MAP 21 condition on the bottom of that page. In other words, if you look at the part of that test section that was in pre-treatment poor condition, there's in the case of this plot, there's about a 7-year life extending benefit before you get back to what cracking was before that treatment was applied. And then if you look out at year 7, you've got about half the cracking at year 7 that you would have had this treatment not been applied. And now this is a 50% fine fractionated wrap Thinlay, so it's just strictly a volumetric design. It is not a balanced mix design. I think it's about a 54% binder replacement mix. So you're seeing cracking even when you've got good, fair, or poor condition. And you can see the benefit of having a more balanced mix design when you look at the virgin Thinlay on Lee Road 159. This was also a volumetric design, but it is more of a balanced mix design because it had no recycled material in it. And you see much flatter curves for the treated portions of the test section. The Thinlays that we put down on 280 down south and in the northern test sections, those were balanced mix designs that have a healthy amount of reclaimed and recycled material and a healthy amount of virgin binder in them. And we are seeing good cracking performance from those sections as well. So this does, comparing those two plots, you can pull these up on your own through the URL that we'll provide. That stresses the importance of balanced mix design for preservation Thinlays. So really quickly, some takeaways from the southern hot sections. Cracking is a distress that's changing over time. We have less cracking in sections with more robust treatments, as you would expect. Really good performance from double micro, multi-chip, from Thinlays, from Cape Seals, and we see the benefit of crack sealing. You need to exercise caution if you're doing multi-layered chip seals when you have heavier loads or higher traffic, because you can see flushing and or bleeding if you don't back off on the rates, and that can kind of be a complicating factor because you don't really know how much to back off on the emulsion rates and not unintentionally negatively impact performance. But we're seeing excellent performance on many of the treatments that we have in the hot test sections. On Lee Road 159, now it's been down for 9 years, and the only work we've had to do out there, we did have an ultra thin bonded wearing surface that debonded, and it debonded because of some flooding that occurred out there and some water infiltration in the buildup. We did have to mill and inlay one of the lanes. The other lane is still in service and doing well, and that was the only test section out there that really we had a significant issue on, and it was because of some ditch flooding that occurred at that specific location. And we've had to do no maintenance and replacement on US 280 after 6 years. That's a really high traffic roadway. I think it's, Adriana, I think it's close to 20,000 ADT now out there. So it's very, very high traffic, and all the preservation treatments are doing really well. Kudos to our northern partners, the MnROAD team, because they go out there when it's bitter cold and do things like measure crack widths, that type of thing. I think when this picture was taken, it was something like -30 to -35 degrees Fahrenheit without the wind chill. So very aggressive conditions out there. That multi-layer chip seal issue that we talked about with heavy traffic, we've even seen that up north. Of course, in the northern half of the experiment, we changed to regionally appropriate aggregates and regionally appropriate emulsion grades and binder grades. So we didn't use our southern stiffer binder grades for the northern test sections. We went with what was regionally appropriate, and we have seen the same kind of thing. So with the triple layer chip seal, there's flushing and bleeding. You see a little bit of that with the double, but it's not such an issue on the lower volume roadway. Double layer microsurface, similarly up there, looks good. You do have some reflected cracking and specifically that reflected thermal crack, but it's not a high severity situation. Looks pretty similar in a lot of ways to the northern 3/4 inch BMD Thinlay that we put up there. That's a 20% binder replacement mix design. So all these sections are still in service, and we're continuing to monitor them. We did not do cold recycling on 8 or 169 just because of the complexity of adding that additional mobilization to the work that we did, because we did it in a really compressed period of time. So we came back in 2019. Our MnROAD partners worked out a contract relationship with the local cities of Albertville and Otsego on 70th Street, which is the access road to the MnROAD facility. And there's a ready-mix concrete plant behind you as you look at this picture. So you've got loaded ready mix trucks that are moving out away from you, and then you've got loaded material trucks that are coming towards you. This is a relatively thin pavement. I think it's 4 inches thick for most of the road, and it's on a kind of a wet base and a wet subgrade with extreme freeze thaw, and you see a lot of spot maintenance has been done on this road. This is a great candidate to do cold recycling and do it in a way where the cities ended up with a road that was in much better condition, and then we had the opportunity to learn a lot. The original plan was to do both lanes, but we only had Monday through Friday to get this done. So we ended up really focusing on the eastbound lanes. We did a few things in the westbound lane, but it's the eastbound lane that I'm going to share data with you from. And we've got the first two sections there are FDRs, and then you've got cold in-place recycling. You got the cold central plant recycling with a sandwich between a hot mix inlay, and then you've got a 1 inch thinlay that's on top of everything. So for each of these treatment options, you've got a foamed section and an emulsion section. I want to point out to y'all, because we've probably got a lot of people here that are from the South that are watching this presentation. These FDRs are not cement focused FDRs. These are bituminous FDRs. So there was concern with the northern states that fund the experiment that, hey, if we load these up with cement, even with careful strength designs, we may set ourselves up for some aggressive cracking that'll reflect. So these are bituminous FDR test sections. So this is what the finished road looks like. We were able to do this in a week. Kudos to our partners at MnROAD. They were great to work with, and traffic control was a challenge, and the logistics were a challenge, but many thanks to our private sector partners that worked with us to make this happen, like Working and RoadTech and many others that mobilized to help us. This is what the striped and shoulders pulled up and grassed Thinlay surfaces look like. Now I want to give you an update on our data here very quickly, and I've got this on a scale that is approximately the length of the test section. So this shows the longitudinal cracking that has been mapped in these sections. So we've just got a few sections where we have some significant longitudinal cracking, and I think it's out near the edge line stripe. Transverse cracking, we do have some significant reflected transverse cracks. Surprisingly, the FDR sections have a lot of transverse cracks in them, but now this is 4 inches of asphalt that's blended up with this kind of soil ag base, and these are emulsion FDRs. They're bituminous FDRs. They're not cement, the stiffer cement FDRs. So I guess it's not surprising that this has happened, but the cold in-place recycling and the cold central plant recycling and the hot mix, they look great. Very little cracking that's reflected, and it's kind of interesting to see that the FDRs, the cracking in the FDRs is pretty similar to the cracking that's just the 1 inch overlay. But I really expect that to differentiate and to separate out significantly as we go through time. So these sections have been through 2 winters now, the winter of 2019 and the winter of 2020, and everybody's really pleased with performance. So I think the takeaway from this is we've seen amazing performance in all these test sections, but a little bit of healthy spread in the data. So takeaways from the north, as we said, roughness is the distress that is really separating everything, but excellent performance, again, just like we've seen down here. The region up there is they plan to do microsurface on the US 169 control sections, or they did it in the fall of 2020. So some of the control sections on 169 are now out of service, and that was because of the raveling that was occurring out there. The county does plan to level that aggressive thermal cracking this summer, so I guess they're going to go in there with some mastic crack sealing type products to try to close those up for maintenance purposes, and we'll capture that as we collect the data. The quote from our friends at MnROAD is, "Preservation treatments have extended pavement life." That's exactly what we wanted to prove and what we wanted to capture here. But again, both the low and the high traffic Cape seals are performing well, and we see really similar performance trends between the northern sections and the southern sections. For practical implementation, this is something that's really useful for both state agencies as well as counties and cities. This is looking at the data, the most recent vetted data that we have. This is cracking data, and essentially it's percentage cracking improvement data for pretreatment, poor, fair, and good. And what you see is that there's a lot of similarity, regardless of the pretreatment condition of the pavement surface, between double micro, a triple chip, a virgin Thinlay, and a Cape Seal. The numbers are very, very similar as you go from poor to fair to good. That really simplifies your decision-making process because you have the option to look at your market and say, all right, what is going to be my turnkey cost per lane mile for each of these treatment options? That might be a really simple way to implement that into your decision process without having to get into the weeds in your pavement management data, which is certainly an option for you to do based on the life extension and benefit and condition improvement curves that we developed. So your takeaways, there is a good mechanism here where you can select your preservation options based on your life cycle cost. We see the importance of good materials, good designs, good construction, and good inspection. I'm going to provide you with a URL to see some of this data. If it asks you for a username, it's Asphalt Research, all lowercase with no spaces, and the password is 2018 track with a capital T. So here's an overview of the Southern experiment. This is data access for the Southern experiment, and that's where it's going to ask you for a username and a password. To get to MnROAD from the NCAT site, that's the web address. At Minnesota, you can get to their part of the pavement preservation experiment using this URL. You can do a screen grab of this and capture it, or I'm sure these presentations will be provided at a later time. And if you're an agency that wants to look at participating in this pool fund because it is ongoing, we're in long-term data collection and reporting, that's the link to the pool fund website. A big takeaway is you see the value of robust and combination treatments. You know, when you spend a little more money, you're going to see a better performance. That might be a good investment for you. And we do see similar trends, which is very, very encouraging for us. This research was unique because we had the same team, the same contractor at all of these locations, which is a really difficult thing to pull off. And kudos to the MnROAD partners for supporting us in doing that. And we just use regionally appropriate materials for the different test sections in the different locations. We are hosting a conference here, June 22nd, 23rd, and 24th. The middle day is the main day where we're going to be focusing on preservation, although there's a little bit of content on all 3 days. And if you're interested in attending, you can go to ncat.us and you'll see a link where you can register for this conference. There is an in-person option and a virtual option that we would invite everyone to. And there's my contact information. I enjoy working with Adriana or Dr. Vargas in the execution of this research, but if there's anything that I can help you with, I'd be very happy to follow up with you at a later time. Thank you, Adriana. Back to you.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.